In this lecture, we are going to discuss about numerical on a synchronous motor drive. A synchronous motor drive is controlled by the load commutator inverter, which in turn fed from the line commutator converter. The source voltage is 6.6 kilovolt, 50 Hz. Load connected inverter operated at a constant firing angle alpha L of 140 degrees. When rectifying alpha L equal to 0 degrees, the DC link inductor resistance RD equal to 0.1 ohm. The drive operates in self-controlled mode with V by F ratio. The motor has details 8 megawatt, 3 phase, 6.6 kilovolt, 6 pole, 50 Hz, unity power factor, star connected, synchronous reactance XS equal to 2 ohm, RS equal to 0. Determine the source side converter firing angle for the following: motor operation at a rated current and 500 rpm. What will be the power factor developed by motor? So whatever the data is given, that inserted into this circuit diagram. This is nothing but a self-controlled synchronous motor drive with a load computation. RD value is given 0.1 ohm. At a 50 Hz, the motor speed is 1000 rpm. How do you get this value? Means NS equal to 120 F per P. Here the frequency is 50 Hz, that is given here. The 6 pole is given, so the motor speed equal to 1000 rpm. Now the per phase voltage is equal to 6600 by root 3. We are getting the 3810.5 volts. Synchronous reactance is given in the numerical, that is 2.8 ohm. The rated power of the motor is given 8 megawatt. Mechanical power developed in synchronous motor, that is equal to 3 Vs Is cos phi. Substitute all the values and find out the Is. Now Is equal to 699.82 amperes. Nothing but the current which is passing at this point is Is. That we are getting the 699.82 amperes. Or the DC link current. The DC link current ID equal to, so substitute all the values, you are getting the 897.55 amperes. The load commutator inverter operates at a alpha L equal to 140 degrees. Therefore, the phase angle between the minus Is and Vs will be 140 degrees. So the phase angle between the Is and V will be 180 minus 140 becomes a 40 degrees. For operation at 500 rpm, now we are going to find out how much frequency is required. For 1000 rpm, it requires a 50 Hz. So 500 rpm, it requires a 25 Hz frequency. And to maintain the V by F ratio is constant, so I have to find out the corresponding voltage also. When you apply the 50 Hz frequency, this much of voltage you have to apply. If you apply the 25 Hz, this much of voltage you have to apply to the synchronous motor, that is the 1905.25 volts. Now the mechanical power developed equal to 3 Vs Is cos phi. Now here 1905.25 volts into 699.82, the same amount of current will be taken by the motor even though 500 rpm, cos of 40 degrees. So finally you are getting the 3.064 megawatts. Now for the 3-phase load commutator inverter, VDL is nothing but the input voltage of line commutator inverter. We have a direct formula, that is equal to 3 root 6 pi Vs cos alpha L, that is equal to 3 root 6 pi. So you take this value here, voltage 1905.25 cos of 140 degrees. You are getting the minus 3413.9 volts. Now VDS equal to minus VDL plus ID into RD. You are getting the, now you have to take this voltage here and you are getting the 3503.67 volts. Now this voltage equal to 3 root 6 by pi Vs cos alpha S, because it is a source side converter will be operating as a rectifier. Substitute all the values and find out the cos alpha S. You are getting the 66.85 degrees. Regenerative braking operation at a 500 rpm. The rated motor current also calculate the power supplied to the source. When the synchronous motor is operating in a regenerative braking, alpha L becomes a 0. But the current taken by the motor becomes a rated current. But the speed of a synchronous motor is a 500 rpm. Already we have calculated the source current, that is the 699.82 amperes. The DC link current also we have calculated 897.55 amperes. We have taken same value. At 500 rpm, we calculated the how much voltage you would apply here. That is the 1905.25 volts. Line side inverter operating as a rectifying alpha L equal to 0. The machine operates at a pi equal to 0 or unity power factor. So the mechanical power developed in a synchronous motor, that is equal to 3 VSIS cos pi. So why actually this is the power taken by the synchronous motor, that we have taken as the mechanical power developed in a synchronous motor because we neglected the losses in a synchronous. Substitute all the values, finally we are getting the this much of watts. Assume negligible losses in both converter. So whatever the power we are giving here, the some amount of power will be wasting here. The remaining power is goes to the supply. So the power supplied to the source, that is equal to the mechanical power developed PM minus ID square into RD. Substitute all the values, then we are getting the 3.919 megawatts. For a load commutation converter, we are finding how much voltage this one VDL and VDS when the same drive is operating in a regenerative brake. The VDL equal to 3 root 6 by pi Vs cos alpha L, where alpha L is nothing but 0 degree. Substitute all the values, we are getting the 4456.6 volts. VDS equal to this voltage minus VDL, substitute all the values, we are getting the minus 4666.8 volts. Now VDS equal to 3 root 6 by pi Vs cos alpha S. Substitute all the values and find the value of alpha S. You're getting the 113.9 degrees. Nothing but in regenerative braking, this converter will be operating at a firing angle 0 degree, whereas this converter will be operating at a 113.9 degree. Synchronous motor will be running at a 500 rpm, which is taking a rated current. So by the time how much power it is given back to the source means this much of power will be given back to the source due to the regenerative braking of a sync. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of the YouTube channel, so that I'm always welcome to answer all your